hope you have tried the practice questions in the article. So in this video I'm going to discuss those 3 practice questions in the first order differential equations separable equations method. So here we have a separable equation, dy by dx equals 2x 1 minus y squared. So first of all, to solve this type of equations, we have to separate x and y variables both sides of the equation. So I'm taking 1 minus y squared to this side and dx to the other side. So here we get 1 over 1 minus y squared dy equals 2x dx. So here we can see we have like this. So it is easy to integrate 1 over 1 minus y squared dy equals integral 2x dx. Integral 2x dx. So here to integrate this, we can go for partial fractions. 1 over 1 minus y squared can be written as a over 1 minus y plus b over 1 plus y. So here I'm not going to describe how to take partial fractions. Hope you guys know that 1 minus y squared can be written as 1 minus y into 1 plus y, and here this is a method we can write the partial fractions for this. So by simplifying this further, we can take values for the constants a and b. So here by comparing the coefficients, we can get 1 equals a plus b and 0 equals a minus b. So here we get a equals b, and from these simplifications we can get a equals half and b equals half. So by substituting the a and b values for this equation, we can write here 1 over 2 1 minus y dy plus 1 over 2 1 plus y dy equals integral 2x dx. So when integrating this, we can write 1 over 2 ln 1 minus y divided by minus 1 plus here we get 1 over 2 ln 1 plus y over 1 equals, so integrating 2x we get 2x squared over 2 plus c we can write where c is an arbitrary constant. So so we can simplify this further. Ln 1 plus y divided by 1 minus y, because we have minus here, and so because we know that we can write ln x minus ln y as ln x divided by y, so I'm using this here. So here we can write this 2 to 2 cancel out, x squared plus c. So we can keep the solution as this as well as an implicit solution. We do not need to take the solution like this y equals, because the question does not ask us to keep it in the explicit way. So it's easy, we can keep the solution like this. So okay, then moving on to the second part of the question, second equation, we have dy by dx equals xy x plus 1. So in this question also we need to first separate the variables y and x into the both sides of the equation. So we can get this y to this side, 1 over y dy equals x over x plus 1 dx. So it's easy to integrate now. Integral 1 over y dy equals integral x over x plus 1 dx. Okay, so integral 1 over y can be written as ln y equals integral x over x plus 1, can be simplified using partial fractions again, or we can do simple simple adjustment like this. We can add 1 and we can subtract 1. So so here x plus 1 minus 1 gets x, so we can do a simple adjustment, so we can easily simplify this. So integral 1 dx minus integral 1 over x plus 1 dx. So we get ln y equals x minus ln x plus 1 plus c, where c is an arbitrary constant. So here also we can keep the solution as it is in the implicit form, or we can to exponentiate both sides. E to the power ln y equals e to the power x minus ln x plus 1 plus c, and here we get y equals e to the power x minus ln x plus 1 plus c. So we can keep it like this, or we can keep it like this, both are okay. So that is how we solve the second question of the separable equations. So moving on to the third part, third question, which is the last one in this practice questions of the separable equations. We have 2y dx plus 3x squared dy equals 0. So in this one also we can separate the variables in the sides of the equation mark. So here we can take 1 over 2y dy equals minus 1 over 3x squared dx. So easily now we can integrate both sides. 1 over 2y dy equals integral minus 1 over 3x squared dx. So integral 1 over 2y can be written as 1 over 2 ln y equals, and this can be written as minus 1 over 3 x minus 2 plus 1 minus 2 plus 1 plus c, where c is an arbitrary constant. So half ln y equals 1 over 3x plus c. So we can keep the solution like this as well, or we can keep the solution as the implicit solution as this, or we can take the equation like y equals to bring it to the explicit form. So we can write 2 over 3x plus 2c, and here we can write y equals e to the power 2 over 3x plus 2c. So right, so this can be the explicit solution of this equation. So we have done the separable equations like this. So hope you have a clear understanding now about how to do the separable equations. So stay tuned for the next topics of the discussions. Thank you.